All right, for this homework, we're going to look at arithmetic sequences and series. So starting with number 1, it says that we're given that an arithmetic sequence has a first term of 4. So that means we know that A1 is equal to 4, and it has the common difference of -2. Since it's arithmetic, we know that it adds that same number over and over again. So for the first term, well, we already know that. We want to find the first 5, so I'm going to use the notation A2, A3, A4, A5. And so to find A2, we're just taking 4 plus that -2. So it's the term before, add that -2, which makes 2. Then we're going to take that 2, and again add another -2, which makes 0. We're going to take that 0 plus -2, and that will make -2. -2 plus -2 gets us that we have -4. So those are the first 5 terms. Now it wants us to write an expression for the nth term. So if you think about what we're doing, to find like the 5th term, look what we had to do. We had to add 1, 2, 3, 4 -2s to get to the 5th term. To get to the 4th term, we had to add 1, 2, 3. See how it's 1 less? And it all starts with this very first guy. So we know we want to take whatever the first guy is, and then we're going to add a whole bunch of whatever our common difference is. And it's always 1 less than where you're at. So for us, our sequence that we've kind of written about here in part A will be the nth term will be found by taking the first term, which is 4, plus n minus 1 times our common difference, which is -2. Now you could simplify that, but that would be a perfect expression there for our nth term. So to find the 30th term, we want to find A with that little 30. It's going to be found by taking still that number 4, that's our first guy, plus, well, n minus 1 means 30, that's the term number we're on, minus 1, so 29. We're going to need 29 of those -2s. So this will be equal to 4. 29 times -2 is -58, which will equal -54. That's our 30th term. Now last it wants us to write, or not last, we still have part E. Part D, it wants the summation notation. So remember, this is a way to say add. So if we want to add the first 30 terms, we're going to start, and I'm going to write I equals 1. And we're going to count all the way to 30. And what we're plugging into is this expression. So we're going to write 4 plus, instead of n, I'm going to use I minus 1, just that's a common subscript, times -2. And so there's that notation with summation notation. Or if you had simplified the first expression here, again, if you simplify to be 4 plus -2n plus 2, which is really -2n plus 6. So if you simplified and said that's what my nth term looks like, then another way that you could write the summation is still, I like to use I, but you can use whatever variable you want there to count. Still going up to 30, but I would write -2n, or -2i, sorry. Watch your variables, they should match so we know what we're plugging into, plus 6. Now to find the sum of the first 30 terms without actually finding each of the terms, we found that the sum of the first n terms for an arithmetic sequence takes your first term plus your last term, and it's going to multiply it by how many terms there are, which is 30. Then it's going to divide that sum by 2. So here, A1 was 4. The last term we found was -54. We're going to multiply that by 30 and then divide by 2. So really that's going to be a -50 times 30 over 2, which should equal -750. So I should go back a minute. The sum for that 30th term is going to be that -750. All right, now we want to find the 8th term of the arithmetic sequence. So just notation-wise, that means A8. Now we know A1 and A15. So they're not giving us that common difference that we need, because to find A sub 8, we want to know the first term, well, we got that, plus n minus 1 times that common difference. Well, we know that n is the number term we're on, which is 8. So we know A8 is going to be the first term, negative 2, plus 8 minus 1 is 7, but we don't know what the d is. So we need to figure out, well, if we're saying the first term is negative 2 and the 15th term is 68, well, what could d be? Like, how many d's did you add to get to the 15th term? So let's think about A15. It's found by taking the first term, which is negative 2, plus 14 of those d's, because it's at 15, so you had to add whatever the d was 14 times. And we know that this is equal to 68. So we can actually just solve this little equation here. So let's add 2 to both sides. We get 14d is equal to 70. Divide by 14, that tells us that the common difference is 5. So to find A8, it's negative 2 plus 7 of those 5s, which will get us negative 2 plus 35, which is going to be equal to 33. So we found that 8th term. For number 3, we want to find the 35th term. So it sounds kind of familiar, but if we want to find the 35th term, we got to take the first term plus 34 of the d's. Now this time we don't have a first term. They gave us the 4th and the 22nd. So let's think about that. If we're going from the 4th term to the 22nd term, well, we really want to find out how many d's were added. There's a couple different ways to do this one. I like to think about it like as a little system. So a to the 4th is found by taking the first term plus 3 of whatever our d is. And then we know that that will be equal to 8. Now A22 is found by taking whatever the first term is plus 21 of those d's, and that will be negative 46. And so what we've created is this little system here where we don't know what A1 is and we don't know what D is. Now we can use elimination to solve this little system. If I just subtract them, our A1s will cancel. And so if we minus those, 3 minus 21 is going to be negative 18D. And then 8 minus 46, that's really going to be 8 plus 46, which will be 54. And then if we divide by negative 18, that's getting us that that common difference is actually negative 3. So if we know the common difference is negative 3, we can plug back into either one of these. And if I plug into the top, if I want to figure out what that first term really is, well, whatever it is, plus 3 of those negative 3's is supposed to be 8. So this is really A1 minus 9 equal to 8. So if I add 9 to both sides, that tells me that A1, the first term, is actually equal to 17. So I know my first term is 17, and I know that my D is negative 3. So if I plug those in, that should be able to give me my 35th term. So let me undo that. A35 should be equal to 17 plus 34 of those negative 3's. So this is going to be 17, and then when we take 34 times negative 3, grab my calculator here. 34 times 3 would be 102. So we're going to get negative 102. And then when we combine negative 102 with that 17, it gets us a negative 85. So that's our 35th term. Now there's a few other different ways that you can kind of think through this without setting up a system. Knowing again that you go from the 4th term to the 22nd term, you could say, okay, well, I know that that's going to add 18 D's by the time I get to it. So you could kind of think through it that way. Either way works out fine, as long as you get that 35th term is negative 85. All right, for number 4, we want to find the number of terms in this finite, and we know it's not infinite, arithmetic sequence. So we know that this guy is the first term, and we know that this is an, where we don't know what n is. That's our question, right? We want to know how many terms there are. But if you look at it, because it's arithmetic, we have to think about, well, what's the common difference? It's adding 6 each time. So I know that this nth term, which happens to be 320, is equal to the 8 plus a whole bunch of n's. I mean, a whole bunch of those d's, n minus 1 of them. So if I solve this equation, this is going to be 8 plus, distribute 6n minus 6. 320 is equal to, combine 8 and negative 6, that's a 2 plus 6n minus 2 minus 2. We're going to get that 318 is equal to 6n, divide by 6, and we get n is equal to 53. So that tells us that 320 is the 53rd term. All right, and then moving on to the last two, again, just making sure we're familiar with all of our notation. So we know that this is a function, and if I'm going to graph that, it's a line, and it has a y-intercept of -1. The slope is 2, because again, it's in that form, mx plus b. So we're going to go up 2 over 1, up 2 over 1, and here x can be anything we want it to be. Its domain is negative infinity to infinity. Now, when you go and you look at a sub n, this is telling us that we have a sequence. And for that, because we have like a first term, second term, and so on, our domain for this guy is only going to be whole numbers. So we can write that as a set, 1, 2, 3, and so on. And so what that looks like, if I want to find the first term, it's 2 times 1 minus 1, which is going to be 2 minus 1, which is 1. A sub 2 will be 2 times 2 minus 1, which is 4 minus 1, which is 3. And if you keep doing this, I mean, it's going to look very similar. Oops, what did I just do? Did that multiplication in my head. Let's see. So we're still subtracting 1. 6 minus 1 is 5. So what this first line means is we plug a 1 in, we get 1. So that's going to be that point. The next one we plug in a 2, we get a 3. The next one we plug in a 3, we get a 5. So it's those distinct points, and we will not connect them. But you can see that it's forming the same, it has the same slope because you're adding 2 every time. So it's going to go up 2 for every number that you increase by 1. And it's not going to go to the negatives. It's going to keep going up by 2. And so it would look something like that.